Okay, guys, do you guys hear me? Okay, guys, can you guys hear me? Yeah, give me a signal where you can hear me.
Yeah.
Okay, perfect. So let's give it one more minute. Okay. Yeah, here is the first lecture. Always people have some technical issue for the first lecture. I'm still receiving some requests to how to log into the classroom. Let's give it one more minute before we get started. Yeah, like I keep saying, I wish you guys to be here a little bit earlier, especially for the first lecture, because there are a lot of last-minute requests saying they can't find a URL, so on and so forth. One more minute, and we can get started. All right, I think we can get started. Okay, guys, morning, guys. Welcome to our lecture. So before we really get started, I want to give you guys a little bit introduction about our lecture, how our lecture works, the organization, to give you guys a quick idea how we're going to collaborate in the next 10 lectures. So basically, I want to say that this lecture is considered to be the North American Math Contest Knowledge Lecture. If you guys been to my boot camp, like the difference between the boot camp is the boot camp, we're gonna squeeze all the knowledge in 10 lectures, give you guys a blast, flash everything pretty quick. Well, in this knowledge-based lecture, we're gonna be more granular, give you guys more detailed explanations for all the concepts in the North American math competition. In the North American competition, the math part, we basically contains 4 major sections: algebra, geometry, counting and probabilities, and also number theory, right? And I think the number theory is more independent. So basically, we already introduced that in our last several weeks. Well, algebra is actually a more broad section. It contains a lot of subdomains, let's say trigonometry, inequality, polynomial, and sequence, so on and so forth, or maybe function, so on and so forth. So that being said, in order to help you guys have a very good understanding for all the concept, gradually, we designed such a lecture. So these lecture actually, we basically break them into different sessions. Each session, we're going to cover one topic or 2 topics. Make sure we can have a very comprehensive understanding for the topics that will be tested in the North American math competition. All right. And for this session, we're going to focus on the sequence part. Okay. Before we get started, as you can see my screen, we're going to give you some quick, short and brief introduction how our lecture works. The first one is interaction. I always believe interaction is something more than important. Regardless, you're actually doing a face-to-face lecture like the normal days, right? You do face-to-face lecture, or in a specific time like this pandemic crisis, we're doing this virtual lecture. Nevertheless, the most important thing is the interaction between the teacher and the student. Especially in my lecture, I really advertise this interaction. There are actually 2 ways for you to interact with me. The first one is you can basically unmute yourself and talk to me directly. As you can see, when you enter the classroom, by default, you'll be muted. But during the entire course of the lecture, if you want to talk to me, if you get a question, or you think what I'm talking doesn't make sense, always let me know. Do you know how to unmute yourself? You can put your cursor on top, overlay your graph, your profile. On the right top corner, there will be a unmute highlighted in blue. You can basically unmute yourself and talk to me. That's for one way. This is, I think, more efficient way. Well, the second way is you can chat with me through the group chat. So how the group chat works, if you look at your control console, you're going to see mute, stop video, security, so on and so forth, right? In the last option of the menu, you're going to see 3 dots saying more. You can click the 3 dots and there will be a drop-down menu saying chat, right? That is actually our chat board. During the entire lecture, I'm actually monitoring the chat board to make sure I can see all your questions from time to time. All right, so you have 2 ways to talk to me. Either you can basically chat to everyone. So that being said, everyone can see your question, can see your response. Or if you are not so sure, a little bit, not so comfortable, what you can do, you can chat with me privately. There's a private chat option. So that being said, your answer and my feedback can only be seen between you and me. It's up to you guys. You can choose whatever way you like. But nevertheless, I want you guys to participate in the process, which is extremely important in our lecture. All right. Second part, I want to talk something about homework. I believe homework is a very important extension of our knowledge and of our lecture. All the homeworks are actually specially designed. So these homework either are similar to the sample questions we introduced during the lecture, or they can reflect some very important mathematical thought we introduced in our lecture. So that being said, doing the homework is always more than important. So how it works is every time after the lecture, I'm going to give you 3 problems as a homework. Not a gigantic big number, right? 3 problems. And you have actually 1 week to finish the entire homework. As long as you finish the homework, you can submit your answer from Google Classroom. I have already invited you guys to the Google Classroom. If you didn't get the invitation yet, no problem. Talk to me after the lecture. I'll resend the invitation. As long as you accept the invitation, you will be able to see the homework, see the preview, and all the useful materials that I published in the Google Classroom, and you can submit your homework. And normally, I want you guys to submit your homework 1 day before our lecture. Let's say our lecture focus is Sunday, right? 8 o'clock in the morning, 8:30 in the morning. So I wish you guys can at least submit your homework 1 day before. You can do that maybe, I don't know, 7 p.m. Saturday to give me a little bit bandwidth. I can mark your homework and give you the feedback. As long as I find you do a good homework, what I'm going to do is in the next lecture, I'm going to ask you to present your homework. So trust me, I'm not going to make you like a fool. As long as I ask you to present your homework, meaning that you did a good job. So always more than confident to do your homework. Okay? And the last one is the presentation. I believe these days, if you only know, that's not good enough. You need to present it out. If you go to the Google interview, so on and so forth, people keep saying, think aloud, right? So how to walk through the other people basically on your problem and on your solution these days becomes more and more crucial. So every lecture from the next one, every lecture, I'm going to be asking one student to give us a very quick presentation. So you can find a problem, whatever problem you like, as long as they're kind of related to the lectures we are currently talking about. Find a problem and you can just act as a teacher and give us the solution. Sometimes it is always important that you can walk us through the process, not basically read the solution for us, right? Our lecture focus more on how do you think rather than give you the problems one after another. There are millions of problems right there. There's no way for us to cover them all. Well, what we're trying to do, use the limited number of problems, try to reflect the most important strategies and mathematical thought in the process. So that being said, I will ask you guys to find a problem and try to present it. Most importantly, do as a teacher. Find out what is the rationale behind the problem and what is the thoughts behind the problem. So Rome wasn't built in a day. Let's do this gradually by gradually, and hopefully you guys can get a hang of it after several lectures. All right, I think that's a very short and brief introduction to our lecture, how our lecture works. You guys have any questions? Oh, good. Yeah, the last thing is I wish you guys, it's only a wish, this is not compulsory, can turn on your camera because sometimes this is how it works. Based on my experience, Sometimes people, they don't understand, but they feel a little bit shy, so they never ask. So I ask you guys to turn on your camera. I can see your face. Sometimes you really put your answer or your attitude on your face. If I can see you very struggling, something like that, instead of waiting you guys to ask me, I can give you a feedback. So, but it totally is up to you. This is never compulsory. All right, if we're all good, so we can get started. Okay, like I mentioned in the introduction, our advertisement introduction, in this 10 lectures, we're going to focus on a very important topic, which is a sequence. I got to see that sequence is actually a very tough topic in the algebra. If you guys go to either the AMC or the Canadian exams, you always see the last several problems focus on the sequence. Because like I said, number theory is a standalone complicated part. We already know that. But sequence is also a very complicated part in the algebra. Sometimes it gets combined as counting probabilities with the number theories or even the functions and polynomials to give you guys a lot of hard time in the math competition. So we're going to talk about the sequence to give you guys an overview, all the important concepts that you need to know for the North American math competition in the next 10 lectures. So before we get started, let's have some basic overview of like a basic sequence. So sequence, we all know that, right? We use like a curved bracket to denote a sequence. So what is a sequence? Sequence definition is very understandable. It means numbers in a certain order, right? Numbers in a certain order we can call, okay, these are a sequence. So this order actually can be defined in a different perspective. You can have a very strict order. A strict order. Let's say we might be familiar for the arithmetic sequence, right? Arithmetic sequence means what? an minus 1 equals to d, right? Any adjacent two terms, their difference must be a constant value, right? So this is actually a very strong condition. Let's say 1, 2, 3, 4, 5. Each two terms, the difference must be a constant value, what we call a common difference. So this is a very strong order. Or we can have a very loose pattern. A loose pattern, let's say I want to have an increasing sequence or decreasing sequence. Right, these are very loose pattern, right? As long as the numbers start becoming bigger and bigger, these are considered to be the increasing sequence. You can create what kind of sequence as long as they're increasing. So these are considered to be increasing sequence. And same thing applies for the decreasing sequences, right? So this is a pretty loose pattern compared with the strict order we mentioned in the first category. Or we just have no pattern. Let's say I have a random number sequence, which is quite possible, right? A random number sequence. Let's say I want you to toss a coin, right? Every time you have the heads and tails, right? So that one will be totally random. Of course, you have an expectation 50% up, 50% tail, but normally speaking, this is a random number. So the random number can also be considered as a sequence. No pressure, right? Or I can even have the same element, right? As long as all the elements in the sequence, they are the same, we call this is like a constant sequence. Is that right? A constant sequence. So that being said, talking about the order of the sequence is very flexible. You can find whatever you think it is valuable or which is applicable for sequence definition. Okay, that's the definition for sequence. Before we jump to the real content of sequence, let me ask you another question. Are you guys familiar with set? Can I have some interaction? Are you familiar with set? Yes or no?
Not really.
Not really? Then what about the other guys? Set. I want everyone to give me a little bit feedback. So that's going to help me to know where we are and how we're going to organize our lecture, so on and so forth. Okay, I see some of the students that are familiar with set. So I'm just going to say something fairly quick, okay? So the set, actually, I also use the curly bracket, right? 1, 2, 3. So this is also a curly bracket. So people might ask me, oh, Alex, how can I basically find out the difference, differentiate set and sequence? So this can be 1, 2, 3 as a sequence, and this can be 1, 2, 3 as a set. So basically, there are two major differences between the set and the sequence. If you're not so familiar, it's not a big deal. This is outside of today's lecture scope, but just want to give the guys who are familiar with the concepts a little bit heads up. The very important thing, two differences between sequence and set. One is order. Matters or not. For set, the order does not matter. 1, 2, 3, 3 to 1, they're considered to be a set. For instance, I gave an example. Your family members can be considered as a set. You, your parents, and maybe your siblings, for instance. So these are considered to be a set. But who goes first? Your father, your mother, or you? It doesn't matter. However, sequence really cares about order. If I want to ask you guys to stand in a row, you go first, or your father goes first. These are considered to be two different orders, right? So sequence, think order does matter. The second part is we talk about the duplicate items. In a set, you are not allowed to have the duplicate items. Again, like I said, if 1, 2, 3 is a set, 1, 1, 2, 3, this is not a set because the set does not allow to have duplicate items. Again, the same thing as your parents, as your, what should I say, your family as an example. I want to collect all the family members of your family, so you can only say I have one father. I mean, in your current family, if you say your father, you've said it once. You can't say it twice, right? Well, sequence, it doesn't matter. You can have the same elements as many as possible. Like I said here, right? The same element sequence, the constant sequence, you can basically have the same elements as many times as possible. So this is not a big deal whatsoever. So duplicates, allowed it. This is for sequence. And duplicates, prohibited. This is for the set. If you're not so familiar with set, this is not a big deal. I just want to give you guys a little bit heads up how to see the differences between the sets and also a sequence. All right. So I want to give you guys a little bit overview what we will be covering for the next few lectures, what kind of important topics we're going to discuss for the sequence section. The first part, we're going to talk about the basic properties. We're going to introduce the basic information of the sequence and trying to give you guys a little bit, overview how the sequence works. Second, we're going to introduce some very important property, very important elements of the sequence. For instance, we're going to introduce the general formula or a recurrence formula. The general formula and the recurrence formula are two very important ways to denote or to describe a sequence. From more often than ever, you're going to use this very important tool to give you guys idea how to denote a sequence, how to investigate the properties of a sequence. Later, we're going to go to two important sequences. One is the arithmetic sequence. One is the geometric sequence. These are the famous twin brothers of the sequence. Any kind of math competitions you're going to go, you will be asked different properties for the arithmetic and geometric. And also from time to time, they're going to create some problems, not maybe exactly arithmetic or geometric. They can do some elaborations based on the arithmetic or geometric. So this is actually something very important. moving forward, we're going to learn how to determine the sum of a given sequence. Right? As long as you have a sequence, more often than never, they're going to ask you, okay, how to determine the first n-term sum, or first, like a 2 n-term sum, so on and so forth. There are different strategies how to determine the n-term sum. Sometimes you can get it from our general formula. Sometimes you can get it from a recurrence formula. But nevertheless, there are so many strategies behind the scenes, and we need to give you guys a little bit summary to guide you the big direction. If you see something similar, this is what we're going to do in the future. And we're going to introduce a very important proving method. We call it the mathematical induction method. The mathematical induction method is actually a very useful proving methodology for the entire sequence. So it is very important you guys just basically have a heads up on this kind of induction method, and this is going to help you to prove a lot of sequence-related problems. And we're also going to introduce some Fibonacci sequence, some advanced sequences like Fibonacci sequence, periodic sequence. These are actually very important sequences. You're going to see them from time to time. All right, so this is like a quick overview about what we are going to discuss in our following lectures. All right, so far so good. If everything's okay, let's go to our first lecture. We're going to introduce some basic properties of the sequence and give you guys some overview how to solve the sequence-related problems. So today we're going to talk about the basic properties of a sequence. Okay. So talking about the sequence, like I mentioned previously, sequence we're using a curly bracket to denote, right? So this is a number in a certain order, A1, A2, all the way to AN, right? So in order to denote a sequence, the most powerful way is that we find out how the sequence looks like. Is that right? We need to find a formula to denote a sequence. So here, this is a very important concept, which is the general formula. So general formula means I can find a formula to denote a sequence, to find out all the relationship between the sequence and also the n number, right? So the general formula works like this. An can be written as a function of n. Is that right? So n here can be a positive integer. I'll give you an example. Let's say an equals n squared. So that means a1 will be 1, right? a2 will be 4. A3 will be 9, so on and so forth, right? So the general formula give you a way how to denote a sequence as long as you know the n value, right? I think we should be quite familiar with this basic information. Another way, we call it the recurrence formula. Well, the general formula denotes the relationship between n and an, while the recurrence formula, on the contrary, it finds out the relationship between any two terms in a sequence. I'll give you an example. If in a sequence I can say an minus 1 equals to 1, it means that, of course, n is actually belongs to the positive integer, right? So that being said, it means what? The difference between any two consecutive terms, the difference is actually equal to 1, right? So it means that as long as a1, a2 will be a1 plus 1, right? a3 will be a1 plus 1 and plus another 1, plus 2, right? a1, change this, a1 plus 2, a1 plus 3. Right? We find out the relationship between any adjacent two terms. So this is actually a recurrence formula. But trust me, the recurrence formula might not only apply for any adjacent terms. It can be whatever terms. Let's say I have a sequence. An can be written as an minus 1 plus an minus 2, right? It is quite possible. If this sequence I'll start with the first number is 1, second number is 2, then I'll say every number will be the sum of the adjacent two numbers, or like what should I say, the previous two numbers, right? Every item will be the sum of the previous two guys. So A3 will be what? 1 plus 2 equals to 3. A4 will be what? 2 plus 3 equals to 5. And then next one will be 8, so on and so forth. Is that right? So this is also a way how to denote the sequence. All right, try to remember these two ways are equally important. One is the general formula. Find out the relationship between an and n. It means that as long as you have an n, you'll be able to determine an right away. No pressure. Well, the other one, we actually investigate a problem from different perspective, is we call it the recurrence formula. It reveals the relationship between any two terms, or any three terms, or any whatever terms in a sequence. Instead of directly giving you, okay, what does an looks like? From this recurrence formula, it is difficult for you to directly determine what an looks like, right? But as long as you have some initial condition, let's say I tell you a1 equals to 1, a2 equals to 2, then you will be recurrently, gradually determine all the terms in the sequence. Is that correct? So that's actually two ways for you to determine the sequence. And also, for any given sequence, it should have two formulas, a generic formula or the general formula, or a recurrence formula. These two formulas will be working together to give you guys a better understanding of a sequence. So like the two examples I gave you, I'm going to change a different color. So this means will be an arithmetic sequence, right? If you're not familiar with the arithmetic sequence, no problem. We're going to cover that later in our upcoming lectures. Let's just give you a little bit of idea. This is actually what? A Fibonacci sequence. So these are actually two ways to denote the different sequences, and you'll be able to find out. You can be very, what should I say, alternative between the two formulas. All right? So this is the first important thing I want to say, how to present a sequence. Another thing I want to say is the sum of the sequence. So as long as we have a sequence, there are two most important things you need to know. First one is you can find out the an term, right? The first one, you need to find out how an looks like. What is the general formula looks like? Or the second one is how to calculate the first n-term sum. We call it Sn. This is a denotation. Can be written as a1 plus a2 all the way to an. So these are actually two very important concepts that people keep asking in different kinds of math competitions. So I think there's nothing to say about Sn. You just basically add all the numbers together. As long as you know the general formula of an, you'll be able to figure it out. Or if you know the recurrence formula of an, it doesn't matter. We still have different strategies to let you calculate the first n-term sum. Not a big deal. We're going to give you some real problems thereafter. One more thing you need to know is that an can actually be written as Sn minus 1. Is that right? Because Sn is actually a1 plus all the way to an. Sn minus 1 is a1 all the way to an minus 1. So basically, if you do subtraction, you have this is the value for an. I think these are very understandable concepts. All right? Okay. So moving forward, there are some still very important concepts, I think, from a sequence perspective, you guys need to know. Some concepts. The first concept is from the numbers in the sequence. How many items you have the sequence? You can have the finite sequence and infinite. Finite sequence and infinite sequence. So This is quite understandable. Finite sequence means what? The terms of a sequence is finite. You have limited number, only 10 items, only 10,000 items. It doesn't matter, right? As long as the total numbers is already limited, it's a set. So there's a finite sequence. And the other one is the total numbers of a sequence is infinite. Then we call it this as an infinite sequence. So this is a way how to classify a sequence, right? Another one is increasing sequence. And decreasing sequence, right? How to denote the increasing sequence and decreasing? Basically, as long as all the items that are increasing, so this will be increasing sequence, and vice, you're gonna see the decreasing sequence. So in mathematics, we always use some denotations to make it happen. We can say for any given n belongs to here, an plus 1 greater than an, right? Okay, if you're not familiar with here, this is nothing but a denotation. It means for any given. It's nothing but the denotation to make my life a little bit earlier, to make my life a little bit easier. So that's actually for any given. Or you can see arbitrary, arbitrary. So, this A, this kind of looks like an A, right? You make it upside down. Actually, from the letter arbitrary, you make it upside down. It means for any given. Again, it's nothing but a denotation. For any given number n belongs to a positive integer, you always have an greater than an plus 1 greater than an. So that being said, you're looking at an increasing sequence, right? The next term is always greater than the previous term. Same thing applies. For any given n belongs to the big N, an plus 1 lesser than an. So that will generate a decreasing sequence. Is that right? Okay. Another very important concept, we call it the bounded sequence. What is a bounded sequence? Bounded sequence means all the numbers in the sequence, they can't be too big or they can't be too small. Let's say all the numbers in the sequence are lesser than 1 or they're greater than 0. So these are considered to be a bounded sequence. Let me try to, this is like a human language, right? Let me try to use the mathematical language to present it. You're going to find it a little bit different. So I'm going to use such a way. For any given, we just talked about it previously, right? N belongs to the positive integer. I'm going to give you another denotation. This guy, the E uppercase, but I make it turn to left. So this guy means there exists. There exists. Again, nothing but a denotation. There exists M such that an absolute value lesser or equal to M. Then an is called a bounded sequence. Again, for any given n, there exists, again, there's nothing but a denotation. I just want to make my life a little bit easier, more coincidences. There exists a m such that an's absolute value is lesser than m. So when I say the absolute value means can be positive, can be negative, I don't really care, right? As long as I can find such a case, I can say an is actually called a bounded sequence. You guys follow me here? I think this is understandable, right? Okay. Actually, the bounded sequence can be classified into two subcategories. One is the upper bound. One is lower bound. Right? You can be, if everyone is lesser than something, this is actually called the upper bound. On the contrary, if all the elements in the sequence are greater than something, so this is going to be called a lower bound. Right? I'll give you some examples to make sure we are more understandable for those concepts. Let's say I have a sequence an, and an equals to 1 over n. 1 over n. So if I write it out, an can be what? 1, 1 over 2, 1 over 3, 1 over 4, 1 over n, right? So for sure, this is a bounded sequence because all the elements should be what? Lesser than 1, right? 1 is their upper bound. And for sure, they're greater than 0. Then you have two boundaries for the sequence, right? This is quite understandable. Another example is, what about an equals to minus 1 over n? So an will be alternatively positive, negative, so on and so forth, right? Okay, let me change it here. Maybe I'm gonna make it a little bit more flowery, like this. 1 minus n, I mean like a 1 over n times minus 1 to the power of n. So that being said, you're gonna have what? Minus 1, positive 2, minus 1 over 3, positive 1 over 4. So this sequence will be what? If this is our x-axis, it's going to be positive. It is going to be negative, positive, negative, positive, negative, positive, you know, so on and so forth, right? They're up and down, and all the way very close to 0. So for this sequence, you can see, let's say 1, positive 1, right? So they are actually, what should I say, fluctuating back and forth between these two boundaries, right? So this is also considered to be a bounded sequence. Same thing applies if an equals to sine n, right? Again, sine x should be also back and forth between minus 1 and positive 1, right? So an will be this discrete point, right? These will all the discrete point in this sinusoid function, but again, it is fluctuating between the positive 1 and negative 1. So these are actually to be the very basic concepts of the entire sequences. So I hope you guys have some basic understanding. All right? Okay. So after learning the basic concepts, then we need to know what you will be tested in the math competition. In the math competition, if we're talking about the sequence generally, we're not talking about specific arithmetic or geometric. Generally speaking, what kind of sequence? Basically, you'll be tested for the several things. Like I said, one is you need to determine a certain item in the sequence. Let's say the question give you a weird sequence. Okay, please determine what is a 2020, right? What is the value for this guy? This is quite common in the math competition. Or sometimes, instead of asking you what is the value of a specific sequence, like a specific item in the sequence, they can ask you to see if this guy can be divisible by 7 or not, right? You always see the properties of a specific item. Well, the other big direction that the math competition keep testing you guys is how to determine the sum. Think about it, right? That's pretty much all the big directions what you're going to see in the math competition. A specific item or the total sum. Maybe, again, they're not really asking you all the sum, A1 all the way to AN. This is one way. Or on the contrary, some math competitions, they can ask you a sum for a specific block. I'll give you an example. Let's say A1 all the way to I don't know, 800. I'll give you an example. Let's say the question asks you, try to calculate A1 plus A2 all the way to A5. A6, A7, all the way to A10, A11, A12, all the way to A15. 5 as a block, 5 as a block. Okay? So please tell me, this is the first block, the second block. What is, let's say, this 100th block? I think if you guys are familiar with the math competition, they might ask you something like this. Instead of having the entire thing, but just like a block by block, figure out the value for a specific block. So these are also very commonly seen in the math competition. But nevertheless, the two major directions is one, determine a specific item and all the corresponding properties. Two is calculate a sum and then all the corresponding properties. All right, so in today's lecture, let me just try to give you as many problems as possible, try to give you guys a heads up how to basically find out these properties for given sequence. Because the first chapter is very generic, right? We don't have too much to say. This is not even arithmetic or geometric, any kind of sequences. So we don't really have a lot of black and white rules, but basically speaking, these are the two important directions you need to pay attention to. All right, so let's use some real problems to see how we're going to use all these kind of technologies to basically figure out the similar problems. Because math is actually a problem that you need to get your hands dirty, right? So let's go to the first problem. The first problem is a 2010 AMC10B, question number 14. This is an easy problem as a warm-up. I know this is early in the morning. You guys are still feel a little bit drowsy, so try to wake up, okay? The question says, okay, this is an easy peasy question. Okay, the average of the number 1, 2, 3, all the way 89, 89, like 98, 99, and x altogether is 100x. So please determine the value of x. This is an easy peasy question. Everyone, I wish you guys pull out a pen, doing some calculation. So wake up calculation. Okay, tell me what's the value for x. So every problem I'll give you roughly 30 seconds, 1 minute. Think about it. So this problem is fairly easy, right? Nothing really special. You don't really have to learn all the technologies and you know what to do. Get your hands dirty is always important. This one should be straightforward, right? Who can tell me what's the answer for x?
Is x 50?
No.
Okay.
Is it a fraction?
It's a fraction, yeah. It's a fraction.
Is it 5,000 over 99?
5,000 over 99.
Yeah. That's why not.
5,000, no. I think the correct answer is 50 over 101. It's a calculation. 50 over 101. I think you guys all have the right that direction, right? I think the direction should be fairly straightforward. Yeah. So how to do this? The average of this 100 number, 1 plus 2 all the way to 99, right? Then plus x. You divide by 100, right? There are 100 number in total is 100x. Is that right? So what you're going to do is 1 plus 2 all the way to 99 plus x equals to 10,000 x, right? Because you have an x here already. I'm just going to cross out this x. This is going to be 9999. 9999x, right? And then how to count 1 all the way to 99. This is like an arithmetic sequence. But even though you have no idea about arithmetic sequence, because we're going to cover it later, you can try to use the Gauss way, right? When Gauss was actually in his elementary school, he find out this. First one, the last one is 100. Second from the last is also 100. In total, you have what? You have a 50. You have like oops. 1 plus 99. There are 99 terms and divided by 2. Right? This is quite understandable. You have 99 times 2, this buckles or these groups, right? And this guy will be 9999x. So solve this equation. X will be 5 times 99, 9999. So the right answer is 50 over 101. 50 over 101. I think you guys all have some calculation error, but this should be a relatively straightforward problem, right? Like the concept, it doesn't really ask you to do anything flowery. As long as you know how to do the calculation, you should basically solve this problem without any pressure. All good? Okay, this is question number 1. You just basically use the definition, how to calculate the sum, how to calculate the average. You see, this problem is actually a problem testing you with the sum related. Like I said, 2 things. One is sum, one is determine a specific item. Are we all good? You just basically need to harden your calculation. If all good, let's go to the second problem. The second problem is a problem from 2008 COMC. Are you guys familiar with the COMC? The Canadian Open Math Contest, right? This is actually open for all the like the grades, all the grades. This is a problem B3. Let's go to the A part first, and then we're going to go to the B part thereafter. So this is the A part. An infinite sequence, A0, A1, all the way A whatever, right? Satisfies the following: AM minus n, AM plus n, 1 over 2, A2n, A2n. For all non-negative integers m and n. M is greater than n is greater than 0. Okay. First one. Show that A0 equals to 0. Second, if A1 equals to 1, determine the value of A2 and A3. The third one is actually added by me. The original question does not really ask you to do the third one, but I think it's good enough. You can guess out the general formula of AN. Okay, let's have a look at this problem first. I'll give you 30 seconds to finish your writing. Let's try to do this problem together. Okay. You have an infinite sequence, A1, A2, all the way to AN, whatever, and I give you such a relationship. This relationship might be a little bit nasty. You might not see this relationship so often, but it doesn't matter. They can create as many relationships as together as possible, and there's no way for you to cover them all, right? So this is basically such a relationship. So this relationship, who can tell me this is actually what kind of formula? What kind of formula we just mentioned this relationship falls in? Yeah, I see somebody has the right answer. This is a recurrence formula, right? Recurrence formula reveals the relationship between any two terms or three terms or four terms, whatever. Well, the general formula actually give you the relationship between AN and N, right? So this is a recurrence formula. Okay. So for all the non-negative integers, m and n, and m is greater than n, which is greater than 0. So whenever you see a problem which has several steps, always they're gradually by gradually, right? The condition you get from the first step will be helpful for you to determine the second step, and thereafter for you to determine the third step, so on and so forth. Let's try to focus on this one. Show that A0 equals to 0. How to make sure A0 equals to 0? I have to find out A0 first, right? I have to construct out A0 first. Well, the question giving you all those subscripts, they're actually m and n, they're totally not 0. So how can I construct out 0? That's the million-dollar question. Who can tell me how can I construct out 0? By using the condition given by the question. Obviously, this is not a magic, because mn can be whatever numbers you like to choose. As long as m is greater or equal to n, this recurrence formula will hold, right? So that being said, what are you going to do? You just basically find out the appropriate value of mn such that you can find out A0, and your work is done. Is that right? You need to create something. So very obviously, let's say for A part, I just let m equals to n equals 0. Because mn can be whatever value you let me to choose, right? So I just let m equals to n equals to 0. So that being said, the original equation will go into A0 plus A0, because m and n, they're both 0, right? Will equal to 1 over 2 A0, 1 over 2 A0. Is that right? So easy, huh? So that being said, 2A0 equals to A0. So therefore, A0 equals to 0. You see? So understandable, right? Because mn, what kind of numbers you want to do? I just close my eyes, pick up any number which can do me a favorite, and then taking from there, I'll be able to figure out this problem. I think this is a very important strategies you need to know. Well, moving forward, let's go to the second part. If A1 equals to 1, okay, this is actually something very important. In a math competition, if you have several steps, like sub-question 1, 2, 3, everything you get from number 1, they should be applicable for number 2. Is that right? So these questions, question number 1, question number 2, question number 3, they're actually gradually by gradually. All the conclusions you get from the first one, you can actually use it for the second one to make sure, right, you can get what you need. So for the second one, the question asks you what? A1 equals to 1. Of course, A0 is also equal to 0. This is what you get in the first question. Determine the value for A2 and A3. Okay, let me try to drag it here. Let me rewrite one more time. AM minus N, AM plus N. Okay, now I already have A0 equals to 0. A1 equals 1. This is actually a condition given by the question, right? With all of this, the question asking to determine A2 and A3. Let's have a look. How are we going to solve this problem? First of all, I think this problem falls into our big two categories. Either determine a certain number, like a certain term in the sequence, or you determine the sum. This question doesn't really ask you the sum. A2 and A3, they're actually a certain number, right? A certain item in the sequence. So how to determine A2 and A3? Who can give me some ideas? Before we jump to the real solution, what is the big direction for you to determine A2 and A3? Who would like to say something? We're not really asking the solution. We're asking the big direction. In my lecture, the most important thing is we need to teach you guys how to think, right? Whenever you see a strange question or like a weird question, what is the big direction? How do you get started? This is $1 million question. We need to cover them all. Like I said, there are a million questions out there. You can never cover them all. Even you cover 1 million, there will be 1 million plus one, right? So the most important thing is we need to find out the strategy. From the limited problems, 2, 3, 5 problems, but we find out the big strategy which can be transferable for all the problems. So who can tell me what's the big direction? The big direction for this problem. I think the big direction is exactly the same as question number 1. We need to create A2 and A3, right? If there's no A2, A3 in the equation, how can I do my magic and figure out the value for A2 and A3, right? The only thing that I can do is I need to construct out A2 and A3. So moving forward, I'll be able to figure out a value for A2 and A3. That's the big direction. So how can I construct out A2 and A3? So my big direction is construct out A2 and A3. As long as I have A2, A3 in my equation, I might be able to dance with it and figure out what is the value, blah, blah, blah. But how can I construct out A2 and A3?
You can make M3 and N0, and for A2, make M2 and M0.
Is that right? You guys follow? You guys follow Irvin? The most important thing is that you need to play with the M and N, right? To figure out what is the, how to like create A2 and A3. This is the $1 million question. So, but you're not creating from nowhere. You must create based on something that we already know. What we already know is A0, A1. You need to play with M and N, try to figure out you have what is A1, what is A0, moving forward, what is A2 and what is A3. So just like Urban mentioned, right? We can let me change the color to blue. Let M equals to 1, N equals to 0, right? So that being said, you're gonna have what? A1 plus A1, you just plug in the value, right? This is not the magic. Will be equal to 1 over 2, A2 plus A0. Is that right? You already know the value for A2. Excuse me. You already know the value for A1. This is given by the question. You already know the value for A0. This is what you calculated just momentarily, right? So that's gonna say you're gonna have A2 equals to 4. Isn't it? You just play with M and N, try to construct out what is A2, what is A3, and taking from there, you will get what you need. So this is actually A2. Okay, as long as I know A2, I'm gonna put A2 here as well, 4. I know A1, A0, A2, 3 items. Moving forward, I need to determine what is A3. To determine A3, the same thing, I'm gonna play with MN to figure out what is A3, and my work will be done. So I will let M equals to 2, N equals to 1. You know, that's the only way for me to squeeze out this kind of like A3 thing, right? So let's have a look how this looks like. A1 plus A3 equals to 1 over 2 A4, 1 over 2 A2. I just basically plug in the value. This is not a magic. Okay, A1 I know. A2 I know. I need to know A3. However, not so lucky, I got an A4 here. I can't really solve it, right? Because there are 2 variables in my equation. So what should I do? I think my direction is correct, right? I need to play with the subscripts, 2 and 1, whatever, M and N, whatever, to figure out how can I construct out A3. But even though my direction is correct, I have a little bit of hard time here because I have an A4. I can't really solve this equation within 2 variables. So intuitively, what you need. Whenever you see 2 variables, what you need.
Another equation?
Another equation, right? Like Jiaju mentioned, another equation. It's very understandable. So it means I can't stop from here. I need to do more things in order to construct another equation, but I need to make sure another equation also has A4 and do not generate another variable. If I have another A6, my God, I gotta keep doing this forever, right? I need another A4 and I need another A3, or hopefully another thing to make my life easier. So that's not a magic. I'm gonna let M equals to 2, N equals to 0. You're gonna have A2 plus A2, 1 over 2 A4, 1 over 2 A0. Okay, you see, now it's good. I have 2 equations. Let's say star, star, star. So you have 2 equations, you have 2 variables. A3, A4, A4. Well, the other A2, A0 thing you already figured out. Is that right? So that being said, you'll be able to determine the value for this. So A3 will be 9, A4 will be 16. Is that it? Every single step, there's a reasoning. As long as I come to here, I find out there are 2 variables. Very intuitively, I need to construct another equation. If I find 2 variables, if I find 3 variables, unfortunately, you need to create another equation. Try to make sure you have enough numbers of equations to make sure you can solve this problem. Okay, so far so good. So this is basically the question asked you by the COMC. And I want to ask you another important thing. Please guess out. I'm not really asking you to do a very rigorous proof. Please guess out what is the general formula of AN. So to do that one is super easy. To guess, right, you need to basically have some data to guess, right? You can't guess from nowhere. A0 equal to 0. A1 equal to 1. A2 equals to 4, I think. A3 equals to 9. A4 equals to 16. Then
AN equals to N squared.
it's very intuitive, right? Like Josh mentioned, right? AN will be equals to N squared. This is quite understandable, right? Okay, why I'm giving you this? 2 reasons. First, to have all the numbers, list them out, and then do a guesstimation. this is something extremely important for the sequence. Most of the time, no one is going to really ask you the rigorous process, how to find out blah, blah, blah. As long as you figure out a pattern, we're good to go, especially for the AMC exams. AMC doesn't really ask you your work. As long as you figure out A, B, C, D, E, which one is good answer, you're good to go, right? So this guesstimation is very important. We're going to see in the following questions a lot of problems you need to guess. Second part is, this is number one, guesstimation. Second part is that these days you find out, okay, I just guess it out. But how can I find out a rigorous solution? How can I rigorously prove this? In order to rigorously prove this, you can't really keep writing A4, A5, A6, A7, right? You can never stop from there. What you're going to do is you can actually use the mathematical induction method. Mathematical induction method. This is going to help you to do a rigorous proof. But let's keep it a little bit mysterious for now because we don't introduce the mathematical induction method yet. Let's try to remember this question. After several lectures, when we introduce the mathematical induction method, we'll come back at this problem, and you guys will find out how to give a rigorous proof. Okay? So far, so good? This is for the A part of the COMC problem. Let's have a look at the B part of the problem. So I'm just going to write a problem here, and I'll let you guys go for a quick break, 5 minutes break. I know somebody, I know some students, you can't even open your eyes, right? Yeah, it's too early in the morning. So go there, wash your face, and then we'll come back after a short break. But I'll write a problem first. Within this short break, I want you guys also basically think about the question, okay? So the question says, an infinite sequence B0, B1, Bn satisfies Bn minus n, Bn plus n, B2m plus B2n. It's quite similar with the last problem, right? Maybe they do some adjustment for the coefficient. But anyway, looks quite alike. This one holds for all non-negative integers, m and n. Also, m is greater than n greater than 0. Quite alike with the previous problem. So proof. I have an infinite sequence, B1 all the way to Bn, and I give you such a recurrence formula. Okay? This guy is for all the non-negative integers, mn, blah, blah, blah. Prove that all the terms in the sequence, they have the same value. It means what? This is going to be a constant sequence, right? 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, like whatever, right? So think about it. How are we going to prove this? And now it's like 9:80, 9:39, right? Let's go for a 5 minutes break, and I'll see you guys around 9:45. Okay, think about it. Think about it this 5 minutes. Okay, and then we'll continue our lecture in roughly 5 minutes. Okay, guys, so let's continue. Give me a signal when you're back. Yeah, please give me a signal when you're back, and then we can continue. Okay, guys, all good? Okay, so let's continue. This problem, like I said, it's a COMC problem B part. So it says that an infinite sequence B0 all the way to Bn, right? You have such a relationship, which is quite similar with the previous problem. For all non-negative integers m and n, m is greater than n, prove that all the terms in the sequence, they have the same value. So this is actually a very important problem because I want to show you guys some important strategy, how to prove all the terms are the same. So strategy is always important, right? Strategy. As long as the question asks you to prove all the terms are the same, basically there are only two ways to prove it. The first one is you want to prove bi equals to bi minus 1, right? Any adjacent two terms are the same. So this is basically all the terms are the same, right? It's quite understandable. Or what you can do is you can actually use the parity. You can try to prove all the even terms are the same. All the odd terms are the same. And then you figure out one even term equals to another odd term. Is that right? So altogether, you'll be able to prove everything is the same. All the evens are the same. All the odds are the same. And then you pick up any one, any even, any odd, they can be the same. Though it can be like the liaison, right? Which connects all the even terms and odd terms. And altogether, everything will be the same. I think this is quite understandable, right? Try to remember, in most of the math competition, these are the two very important strategies to prove all the terms are the same. Remember this. So let's try to use one of the strategy to figure out what we're going to do for this problem. Let's do a quick observation. So the original expression, you have it here. You have 2m, 2n here. Is that right? So it is quite understandable. 2m and 2n, they're what? They're even numbers. Is that right? These are even numbers. So intuitively, you might like to solve this problem from this even odd kind of direction rather than bi minus 1 because you can't really find out bi minus 1 in the original problem, right? This is the way how you think. So preferably, this is a big direction, even odd, this kind of things. Okay, so what we're going to do is we're going to let m equals n equals to m, whatever number, or k, whatever you like. We plug in to the original relationship. You're going to have what? B0 equals to B0 plus B2m equals to B2m plus B2m. This is just basically plug in. And then you're going to have what? B0 equals to B2m. Okay. B2m. For sure, this is going to be an even number, right? Because m is an integer. M can be whatever value. Can be 1, 2, 3, 4, 5, whatever, right? As long as m covers all the integers, this B2m covers all the even numbers. So that being said, everyone goes to B0. That being said, means all the even terms are the same. Right? All the even terms are the same. All right. So let's have another quick look. I let m equals to big M, n equals to 0. Let's have a look at, maybe I'm going to be able to squeeze out some other stuff. You're going to have bm plus bm equals to b2m plus b0. Is that right? b2m. This is exactly what I got from here. equals to B0. Is that right? So that being said, Bm equals to B0. Okay, this one is even more interesting. Bm, because m is any kind of number, can be 1, 2, 3, 4, 5, 6, 11, whatever. Every Bm actually equals to B0. So that being said, as long as m travels all the positive integers, Bm travels all the terms. So that being said, all the terms are the same. Is that right? Every single step you need to have a reasoning. Because I see the 2m thing, let me just have a quick recap. I see the 2m, 2n, which give me a hint. Maybe I'm going to go for the I'm going to go for the even or odd direction to solve this problem, right? And then moving forward, as long as I got, okay, all the even numbers are the same, what I'm going to do is I'm going to figure out how does this B0 looks like, because that's the only thing that keeps me a little bit draggy. This is B0. So what I'm going to do is I'm going to construct another one which has the B0. Okay, luckily I find out as long as this one works, Bm equals to B0, because m can traverse all the positive integers, so B0 can actually equal to all the terms in the Bm, right, in the B sequence. So that being said, this is going to be a constant sequence. You see, it's actually very straightforward. You'll be able to make it out. So far, so good. Okay, I think this is not a difficult question. Okay, let's go for another problem. This is a problem from 2008, AMC10B, question number 11. Also considered to be a relatively straightforward problem. Suppose that U1 is a sequence of real numbers, also satisfying un plus 2, 2, un plus 1, un. Same thing, right? The question gives you a recurrence formula. Trust me, this is very common in the math competition. It gives you a recurrence formula. And like I said, recurrence formula, they always need to give you some starting points, right? Some basic, like the base condition. Let's say my note, A3 equals to 9, U6 equals to 128. So please determine what is the value for U5. What is the value for U5? For now, I'll give you guys maybe 30 seconds to think about it. We already introduced this strategy several times, right? Your $1 million question is try to play with your recurrence formula and to construct out A5. Is that right? Of course, you're going to use U3, U6 there, try to help you out. But generally, the big direction is very clear. You need to construct out U5. And taking from there, you'll be able to solve the problem. Right? I'll give you 30 seconds to think about it. And let me know if, so everyone, I want you guys to get involved in the process. Okay? Put out the pen. Tell me, what is the direction? Yeah, I see somebody already has the correct direction. Exactly. So for the other guys, same thing. Maybe instead of giving me the answer, I'm going to ask you one thing. Apparently, I need to play with n, right? I need to give n different values to figure out what I'm trying to do. So who can tell me what kind of n value I need to plug in order to make sure in order to facilitate my work? Who can tell me this? What is the value for n I need to plug in to make sure I can basically find out the direction of U5? Maybe we can ask for Jiajun to give us some ideas. Is that right? N equals to 3 and n equals to 4. Why? Let's have a look. Because my ultimate goal is to figure out A5, right? A5. I need to create A5 first. So let n equals to 3. What am I going to have? U5. Oh, yeah, U5. Yeah, U5 is 2 U4 plus 9. Is that right? Because U3 is 9. I've just put it here. Again, it's exactly the same thing as I saw in the latter question. As long as I have this, I have another thing, U4 here. I need to find another equation to get rid of U4, right? I can't have one equation which contains two variables. So it means my construction can't stop here. I need to do another equation which has U4 or U5. Apparently, I'm going to let n equals to 4. That's going to be what? U6 equals to 2U5 plus U4, right? U6 is already given by the question, 128. I'm going to erase it. 128. Now I have two equations with two variables. Is that right? It's very understand. Every single step, you need to just follow our pattern. Play with the numbers. Try to create what you want. Sometimes one equation is not good enough. You need two. Sometimes two equations is not good enough. You need three. It's up to you guys. So what is the right answer for this? U5. I see Josh already has the correct answer. The other guys, yeah, please participate in this process. This is very important. Who can tell me the answer? I think Josh already has the right answer. Well, the other guys, please tell me what is the answer. You just basically solve this equation. Because I see a lot of students, their direction is correct, but their calculation is always wrong. So you end up losing your points. I think this is easy. U5 should be equal to what? Who can tell me? Come on, just solve this this basic equation, right? What is the value for U5? Should be 53, right? You just basically plug in the value, you'll be able to figure out what it is. 53. All right? All good? If all good, let's go to another problem. This is a problem, it's an old problem, 1998. It's a Euclid problem. It's a Waterloo Euclid problem, number 4. Consider the sequence. T1 equals to 1, T2 equals to -1, Tn equals to n minus 3, n minus 1, Tn minus 2, Tn minus 2. where n is greater or equal to 3, then what is the value of T 1998? You see, all those problems looks very similar, right? You need to be familiar with such a pattern. Same thing, the question give you what? A recurrence formula, right? Like I said, as long as you have a recurrence formula, they need to give you some items to start with. They can't really give you a recurrence formula without talking about anything, right? Okay, as long as you have this, what are you going to do? You have two base scenarios. You have a recurrence formula. The question asks you a weird term, 1998, right? This is quite common in the math competition. Apparently, you won't be able to calculate all the way to 1998, right? You need to find out some pattern. So the $1 million question is, what is the pattern for such a problem? As long as you see such a problem, your first reaction should be very clear. It is impossible for you to calculate a 1998. There might be some patterns behind it to make sure you can somehow figure out what is the value, so on and so forth. This should be a very reasonable value that you can calculate fairly quick, right? So trust me, any kind of the sequence problem, like I said from the very beginning, what you're going to do is you can either start with something, try some, A1, A2, A3, right? And moving from there, you'll be able to find out a pattern. And from the pattern, you might be able to guess out what it is. This is one direction. The other direction is just directly figure out what is the pattern, and then taking from there, you get what you need. You don't really have too much strategies to solve any problem like this. So let's just try to start from my first approach. Do some guess out. The guess out, you just plug in the value. T1 equal to 1, T2 equal to -1, T3, from T3, you just basically plug in the value, right? There's no magic. T3 equals to what? 3. T4 equals to what? Minus 1/3. T5 is 0. T6 is 1 minus 5. So on and so forth. You basically find out, you see? As long as you find out this, an even term is always -1 over, looks like 4 minus 1, right? Even term, -1 over 6 minus 1. If you're not so sure, you can try to read T7. T8 will be -1 over 7. So this is going to be what? 8 minus 1. Is that right? You just find out a pattern. There's no magic. Find out a pattern. So maybe you can guess out. T 1998 will be what? -1998 minus 1. -1997. Is that right? No magic. You just basically write. If you're not so comfortable about T8, you can write another 2 more terms, and that's it. And that is actually the correct answer. Find out a pattern and guess out. This is extremely important for the sequence related problem. Because sequence, what is the sequence? Do you still remember? Numbers in a certain order means a sequence. Certain order, you just need to guess out how this certain order looks like. This is actually the right solution. -1 over 1997. Right? This is the guess out way. Also, like I said, there's another way to prove it is using the rigorous way. Try to find out a relationship between all the terms and find out, what is the rigorous pattern. So let's say this is solution 1. Solution 1. Let's try to do the solution 2. Solution 2 is try to use the rigorous way, and I'm just going to erase it from here. You're going to find out that the rigorous way is very understandable as well. The question asks you, what is T 1998? Okay. According to the definition, I have no idea about 1998, but I know something about 1, 2, 3, right? T1, T2. So I need to lower down the number from 1998. This guy also works for what? 1995, 1997, T, 1996. Is that right? I'm lowering down 2 numbers by using the recurrence formula. And what about this guy? I can further write it into 1993, 1995 times T 1994. Is that right? I keep using this. This 1994 can be further written as 1991, 1993, T 1992. Is that right? So that being said, okay, T 1998 will be written as, I'm just going to put everything together. 1997, 1993, 1995, 1991, 1993. I can keep writing this all the way to 3513 T2. This is like iteration, right? They can iterate all the way to T2. Okay, T2 is what I know. T2 is what? Minus 1. Well, the other terms, as you can see, minus 1. This part can be cancelled. This can be cancelled. All the way, everything can be cancelled. So this is going to be 1997 over 1 over 1997 times minus 1. This is exactly the same thing. You have it here. Is that right? The same problem, we have 2 ways. They're both correct. Either you guess or you do the rigorous way. It doesn't matter. So far, so good? Okay. It felt good. Let's go to another question. 2005. This is Waterloo Cayley problem, number 16. Let's have a look. Okay. The question says, the non-negative difference between 2 numbers, A and B, is either A minus B or B minus A, whichever is positive or at least greater or equal to 0. So we're defined this is like non-negative difference. Whichever A minus B, B minus A, just put like positive. That's it. So for example, the non-negative difference between 24 and 64 is 40, right? You just basically use 64 minus 24. It's 40. Okay. In a sequence, now I have a sequence. So how can I get a sequence? In this sequence, each number after the second is obtained by finding the non-negative difference between the previous two numbers. You see, these two numbers is okay. Now I'm just gonna find the non-negative difference between the previous two, that's 64. Now I'm gonna find out the non-negative difference between the previous two, that's 40, yeah, right? Same thing, so on and so forth. Okay, here's the question. The sum of the first 100 terms of the sequence is what? Okay, so this is how this problem says. So first of all, the problem gives you a definition of the non-negative difference. Just basically you find out the absolute value, that's it, right? And then I give you a sequence. The first two terms I tell you, 88, 24. And then I just keep getting the non-negative difference of the previous two terms from the third, the fourth, the fifth, so on and so forth. With all those information, the question asks you, what is the sum of the first 100 terms? You see, this also falls into our two category. One is determine what is a certain term. Second, you need to give me some sum. First 100, first 1,000, so on and so forth. Think about it. How are we going to do this problem? This is actually, like we keep saying, whenever you see a problem, what's your starting point, right? What is the direction? This is $1 million question. Like I said, every single math competition problem, the numbers are not given for fun. There must be some reasoning behind it. Is that right? If you are like in my old lectures, you should be familiar what I'm talking about. Every single number is given for a reason, not for fun. You're going to ask for yourself, why they give you these two numbers as a start, right? And why they ask you the first 100 terms. There might be some reasoning behind it, right? This is not going to happen randomly. Every single number is given for the reason. All right. If you can't find a reason, like I keep saying, what should you do? Try to list out several terms, right? After you list out some terms, maybe you're going to find out the beauty behind it. Is that right? Our first direction always the same. Try to do some enumeration, right? This is in the mathematical language we call it enumeration. Enumeration means what? List them out. All those patterns, they never come from nowhere. They must come from the observation. But you need to have something to observe. You can't just like rolling your fingers, observing nothing, right? So my suggestion is whenever you see any sequence-related problem, try to list out several terms. The first 10 terms, first 20 terms, if you like, all the beauties will generate from there. Let's have a look. I'm just going to list out. The first one is 88, right? 24, 64, 40, 24, 16. I just keep using the difference between the two terms, right? The previous two terms, and then guess out from there. And then what else? 8, 8, 0, 8, 8, 0, 8, 8, 0. You see? As long as you list out several terms, you find out the pattern right away. Okay, even though I don't know the first like the first 6 terms, right? There's 6 terms. I don't know the magic, like whatever, but I know from the 7th term, this is going to be what? This is going to be a period. 880, 880, 880. Is that right? See, all of these are actually based on observation. If you do not enumerate, there's no way for you to observe. Try to understand. This is very important. Like I keep saying from day one, all the sequence-related problem. List out several terms. Most of the beautiful things will speak for itself after you list out several terms. Okay, so that being said, okay, the first 6 terms, they basically be this. It is what it is. And then every 3 terms, this will be a cyclic rotation, right? And the question asks you, what is the sum of the first 100 terms? Who can tell me? What is that? A1 plus A2 all the way to 100. This part should be easier. I'll give you 1 minute. Who can tell me what is the first n-term sum? Yeah, I see Yijun already has the right answer. Yijun, or because I don't really know how to spell her name, how to pronounce her name. Yes. So maybe we're gonna ask Yijun to give us some ideas why you go to the right answer. You can talk if you like. It's up to you. Okay. Okay, I think Jiajun already has the right answer. Yeah, you're gonna do a 60 thing like 60, like 96 over 3 to find out. Yeah, Irvin, right answer as well. Yeah, I think pretty much everyone has the right answer, right? That one is easy because you just need to figure out in this 100 terms how many you have, right? So basically, the first 6 terms will be here no matter what, and then you have what? 94 terms remaining. In this 94 terms, you will have 31, this 8 plus 8 plus 0 bundle, right? And then you're going to remaining 1 extra 8 term, right? This is 8. Is that right? Extra 8 at the end of the day. So you're going to have totally the first 6 terms. This 3 as a cycle, you have 31. 31 times 3 equals to 93, and you plus another remaining one. There's another 8. So that being said, A100 equals to 8. You add everything together, will be exactly what you need. 88 plus 24, 64, 40, 24, 16. That's the first buckle. And then 31 times 8 plus 0, and then plus 8. This is the remaining 8. Altogether, 760. So far, so good? Any questions? Always try to find a pattern. All the problems will be solved using the patternized solution. If all good, let's go to the last problem of today's lecture. We're looking at a 2004 AMC12, question number 12. It's AMC12 problem, but still same strategy, nothing changed. So this is how the problem looks like. In the sequence, 2001, 2002, 2002, 2003, each item after the third is found by subtracting the previous term from the sum of the two terms that precedent that term. For example, the fourth term is this plus this minus this. Okay? That one equals to 2000. With this information, what is the 2004th term in the sequence? In the sequence, they give us a 2001, 2002, 2003. Each term after the third is found by subtracting the previous term from the sum of the two terms that precede that term. So the fourth one, give an example. The fourth one is actually subtracting the previous term by using the sum of the previous two terms, right? So basically, they give an example. 2001 plus 2002 minus 2003, you have 2000 as the fourth term. Okay, with all those information, what is the 2004th term in the sequence? Again, right, exactly the same thing. We pick up questions from different math competition. We covered the Euclid, Cayley, AMC10, AMC12. They're exactly the same thing. All these math contexts, they're actually connected. Not because of you only want to go to Canadian exam, though you don't even have to look at the American exam. They're totally the same, no difference. Okay, the concepts are exactly the same. So, what is the 2004th term? The solution will be exactly the same as we talk about for the entire lecture. List them out. List them out several terms, and then try to find out the pattern. For the Canadian exams, maybe the pattern is more conspicuous. The American exams, the patterns, you need to think about it, but still nothing but pattern. I'll give you guys maybe 1 minute, list out several terms and tell me the pattern. Okay? Yeah, I see Jiajun already has the correct answer. Yes, 0 is the correct. Yeah, and Yijun as well. Yes. Then what about the other guys? Yeah, I think you got, yeah, I think a lot of guys already have the correct answer. Like I said, you just do some observation. In the AMC, they don't really ask you to give the process, like to show your work, right? As long as you guess them out, we're good to go. Okay, you know what? Let me just try to list out some terms for you guys. Maybe you'll find out what is like the pattern is, right? So, like I said, let's write A1, A2, A3, A4, A5, A6, A7. I think 7 terms, roughly lesser than 10 terms, you already get a hang of it, how it looks like. A1 is 2001. A2 is 2002. A3 is 2003. A4 is 2000. A5 is 2005. 1998. 2007. Right? This is what I list out for pretty much the first 7 terms. Before you jump to find out a pattern, always try to think about here. The question asks you to determine the 2004 term. This part is actually, you need to have like a kind of this conditional react. As long as you're talking about the sequence-related problems, you need to be very familiar about this even number, odd number. This kind of like very sensitive for this, because sometimes even number sensitive, like an odd number, actually give you an idea what is the big direction to solve out this problem. So as the question asked you is 2004, this is actually an even number, right? And also I mentioned in most of the American exams, it might not be so easy for you to find out what is the pattern, but still there will be a pattern. And you say this is an even number term. Maybe the condition or the pattern can be classified into even number terms and odd number terms. It might not be a one big equation, like a one big formula that fits everything. It is possible that you break them into even terms and odd terms. This is quite possible. Plus, the question asks you to determine is an even number term. Let's try to get started with the even number term first. 2008, excuse me, 2002, even. 2000, A4. 1998, A6. I think for now you already get some pattern, right? This is what? 2004 minus 2. This is what? 2004 minus 4. 2004 minus 6. Everything is connected with this 2004, right? Which means we're in the right direction. So that being said, 2004 minus 2 times 1. 2004 minus 2 times 2. 2004 minus 2 times 3. So that being said, all the A2K will be written as 2004 minus 2K. Is that right? This 1 is here. This 2 is here. This 3 is here. So A2K will be written as 2004 minus 2A minus 2K. So that being said means A2004 will be written as 2004 minus 2 times 102 equals to 0. Is that right? As a quick extension, I think that's it. That's already a solution for the problem. As a quick extension, I think this question is nice. It only asks you 2004. If I'm the author, I'm going to ask you A 2004 plus A 2005. That being said, you also need to determine how the odd term looks like. Is that right? I give you 1 minute. Who can tell me what is the odd term? What is the odd term looks like? What is the general formula for the odd term? when you read one problem, you need to do a little bit extension, right? Not only for the problem itself, maybe more than the problem. The question asks you the even term. That's it. You're already done. Then what about the odd terms? Yeah, I see Jonathan already has the correct answer, right? The odd term. Jonathan already has the correct answer. He said the odd term will be an equals to 2000 plus n, but n needs to be odd. Is it right? Yeah. Same thing applies. You can do something even more similar. You see, already have this 2k thing, right? I'm going to construct something quite similar. 2k plus 1 will be 1999 plus 2k. Is that right? 1999 plus 2k. This is going to be the odd term, right? This is quite understandable, right? Figure out this. So if the question asks you A 2004 plus A 2005, you just basically plug in the value for this, plug in the value for this, and you'll be able to figure out what it is, right? This is going to be 0 plus, I think that's going to be what? 5004, right? 5004, 4005. All right? So this problem, what I want to show you guys is that, first of all, you need to find a pattern. Always find a pattern. Second, the pattern might not be so universal for the entire sequence. It might be the even term has a pattern, odd term has a pattern, or even, I don't know, maybe the 1, 2, 3, like 1, 3, 6, 9, all those terms has a pattern. It really depends on different scenarios. But nevertheless, you need to find a pattern, right? And from the pattern, you need to find out what is the properties for the entire formula. Try to remember this is extremely important for the math competition. As you can see, these problems are connected. AMC, Euclid, Cayley, they're all talking about the same thing. All right, as a wrap up of today's lecture, this is the lecture number 1. We basically introduced the basic formula, right? And how we're going to use the general formula, the recurrence formula to determine 2 important things. One is the nth term, any kind of term. Second, the sum. First the n term sum, first the n,000 term sum, it doesn't matter. So the basic strategy is to list them out and find out a pattern. In the following lecture, we're going to give you more flowery problems talking about the same thing. And also, we're going to move on to more specific sequences. Now it's only generic sequence, but later we're going to go to more arithmetic sequence, geometric sequence. Taking from there, we'll find out more interesting problems. All right, I think that wraps up for today's problem. You have any questions for me? All good? Okay, if all good, then I'll upload the assignment to our Google Classroom. You have 1 week to wrap up the homework, and then I'm going to see you guys for the next lecture. Bye, guys.
Okay, thank you.
Thank you. Bye, guys.
Thank you, sir.
Okay.